Welcome back. Continuing kind of looking at chemical reactions, you spent that time doing some practice on balancing the chemical equations, getting recipes that work, tinkering with coefficients, and figuring out what ratio you need. Um, Make sure you have that basic understanding. If you need help, make sure you get a hold of me. Okay. The next phase is looking at types of chemical reactions. Um, Here you're looking at all the chemical reactions, and based on certain things that are going on in the reactant or the product, we can classify them into certain categories. Okay. So our objectives here are going to explain how synthesis reactions occur, how decomposition reactions occur, single and double replacement reactions, and combustions. Those all, and I'm going to walk through them and kind of show you how to identify these and how I kind of look at if I'm given a chemical equation, my thought process of how I figure it out. Some of these are real easy to kind of see and identify. Some of them are a little trickier, so we'll walk through it. Your basic understanding objective is if you're given a chemical equation, you need to be able to identify which one of these it is, what type of reaction it is. Okay. All right. So if you look at this, you slide here, looking at the basic types of reactions. We have a synthesis, we have a decomposition, we have a replacement. Now, the replacements are usually the harder ones to figure out, and they're kind of two subcategories. You're going to have a version A here of a single replacement where one thing's flipping sides or replacing, and a second version where two things are switching. So that's where the single and double. They're both under replacement. They're just more of a subcategory. Um, and then we have everybody's favorite combustion. So we'll look at those and being able to identify those. Synthesize first. Okay. Synthesis means to put together, to make, to produce. Okay. And usually when you make something, you have a bunch of little pieces and parts and you're combining them, putting them all together to make one big project. Say you're making a wood shelf. You got nails, glue, pieces of wood, and you're combining it all to make one object. That's the type of thing here when you synthesize. Okay. Again, think of words like photosynthesis, to produce, to make. So here we're taking very simple things, many simple parts, okay, and we're going to combine them to make a more complex object. Again, if you think of like furniture building, you have all the, or you know, get all the pieces and parts from IKEA. Don't try the instructions, but you got all those pieces and parts, and then you're putting them together to make one thing. That's a synthesis. So what we're going to be looking for is on the reactant side, a bunch of little simple parts, and on the product side, a much, much more complex part. Okay? So for example, you got sodium and chlorine. Okay. Two simple things produce one combination of thing. Okay. You're going to see me give you examples like this. A plus B produces something. These are just generic and you can sub in there anything. In my example here, A represents sodium, B represents chlorine, sodium chloride represents C. So that's kind of the general pattern. But I'm combining multiple things to produce one more complex thing. That's the idea behind a synthesis reaction. Okay, so simple, many pieces and parts to one combined, more complex thing. Okay. A decomposition means to break down. Okay, break down. Usually, you see the word decomposition when you think of a roadkill and it's decomposing and rotting away. So you're getting something that's very complex and it's going to break down into smaller parts. So it's just the complete opposite of a synthesis reaction. Here, I'm going from something very complex and breaking it down into its individual ingredients, if you will. Okay. So in this example, Okay. Very complex looking thing, hydrogen, carbon, oxygen all combined. And I'm breaking it down into more parts. Again, when you look at the generic example, you have a combined thing. This could say C, but A, B, something complex, and you're breaking it apart. Another example is you can actually take water, and as I was with you, you can YouTube this. It's real easy electrolysis. If you take water and apply positive, negative electricity to it, electrodes, you can separate into its hydrogen gas and you'll see a bubble and you're getting pure hydrogen and oxygen out of it. So that's another example of, by the way, that's not balanced, but it's another example of decomposition. So I'm going from a complex thing to a more simple pieces and parts. Decomposition. Okay. Replacements are the harder ones to identify. Okay, here you have things that are going to switch. Replacement reactions involve ions. They occur when ions switch places in the compounds. So they're going to kind of, you think of the square dancing and you switch partners. That's what they're doing here. You're going to either see one thing flip partners or you're going to see two exchange. And I'll show you a couple examples. Okay, again, a single replacement occurs when one ion takes the place of another. So in this example, you might see A plus BC produces B plus AC. So here's what's happening here is A, okay, or C is switching. So C is now is attached to B, but on this side it's now attached to A. So only one thing switched. Okay. So if you look down here, you have potassium, okay, you have water. Down here, what did you have? Potassium, okay, or the OH off of here switched and connected into onto the potassium. So I had one thing switch. So that's single replacement. Double, you're going to have them both exchange partners. So just like it says, single, one thing replaces, double, two things are going to switch sides. Okay. So here you had sodium and chlorine. Okay. So over here I had sodium and chlorine attached. Okay. So over here, chlorine was sodium's partner. Over here, fluorine was is now its partner. Over here, fluorine was attached to silver. Now it's partnered up with chlorine. So here I can see that two things are switching sides. They're both exchanging A, B, C, D. Okay, D and B are both switching. So you have two things that are switching, and that's why it's called a double replacement. That is usually the hardest one to identify, and I'll show you a little trick that I use later to kind of help out with that. Combustions is one of the easier ones to identify and everybody's favorite. It will very all combustion reactions look very similar. They all have oxygen as a reactant. Okay. O2 will always be a reactant. The product, you will always see carbon dioxide and you will always see water in every single combustion reaction. So if you see oxygen on the reactant combining with something, you don't even care what it is, it's a type of fuel. Okay, in this case, it's methane, but you get carbon dioxide and water every single time. You could put gasoline in here, you could put natural gas, you could put anything in here, wood, carbon, whatever it might be, you're going to have oxygen as a reactant, and two things are being produced always. So this is the easiest one for me to identify, and it's usually the one that I look for first. Combustion reaction will always look the same. The only thing that's going to change is what is this fuel, but everything else will always look the same no matter what kind of combustion reaction you're looking at. Okay. So let's summarize and then I'll give you a few examples here. A synthesis reaction occurs when two or more reactants combine to form a single product. So to produce, I'm going from very, very simple things to one more complex things. Okay. Decomposition is just the opposite. So these two are just complete opposites of each other. Simple to complex. Decomposition, I'm breaking it apart. So I'm going from complex down to simple pieces and parts. Replacements, these are when you have single or double. Single replacement, one thing is switching. Double, you have two things switching who they're paired up with. These are the harder ones to identify. Combustion reaction always has oxygen as a reactant, always. It always has carbon dioxide and water as a product. Now, the trick that I use is when I'm tasked with trying to identify, what I do is go in this order. I try to figure out which ones are the easiest to identify, and then by kind of elimination, if I get down to that double replacement, I know it's that. I'm not going to look for that one because that's usually the hardest one to identify. So this is the order that I look at them. I always check for combustion first. That's the first one I look for because to me, it's the easiest one to see. If you have oxygen and then you're producing carbon dioxide and water, boom, I don't have to look at any of the harder ones. The next one I look at is the synthesis one. Okay. So I'm looking for simple parts going into a more complex. That's pretty easy to see just looking at it, not even knowing what the molecules might be. The third then I look at is just the opposite. It's basically as easy is the decomposition one. I'm going from complex to simple. By doing that, I've identified at least hopefully maybe one of the easier ones. If not, then I can look at whether it's replacement. Okay. So by then, if I get all the way down, I know, whoops, that it's one of these. And then all I have to do is identify, is it a single or a double? So again, this is the order that I check. If I'm given an equation and says identify, I'm looking for combustion first. I'm looking for that oxygen, carbon dioxide, water. Synthesis, I'm looking for simple to complex. Decomp, I'm going from complex to simple, and then I can settle in and look for the single double. So that's the order that I check them off, hoping I don't even have to deal with number four. All right. So again, let's go through some of these and look at these. Let's look at this first one. Okay. Zinc, okay, and hydrochloric acid. First one I want to look at is it a combustion reaction? Am I combining oxygen? No. So it's not that. Am I going from simple to a complex thing? No, they kind of look the same. Okay. So it's not that. Decomposition. All right. Let's look and see. Okay. Is it going from complex to simple? No. So now I know it's a replacement. Okay. So now which one is it? So I can at least eliminate that. So I have zinc by itself here. It's with chlorine over here. Hydrogen's with chlorine, hydrogen's by itself. So that tells me that chlorine switched spots. Only one thing switched. So that's my single replacement. So A would be a single replacement. Okay. And let's just do one more example here. Let's look at number or B here. Again, I'm looking for combustion. Is it something combining with oxygen? Nope. Is it going from simple to complex? Nope. Is it going from one big honking complex thing down to simple things? Yes. So B would be an example of decomposition. Let's look at this one. What type of reaction is this? So again, first check, is it combustion? Am I combining something with oxygen? Am I producing carbon dioxide and water? You bet. So right away you eliminated all of them. That's your combustion. Again, very telltale, those three things, and then you have some kind of fuel, some kind of usually hydrocarbon. Again, make sure you can identify these reactions. I really think the kind of key, if I showed you, look for combustion, then go to synthesis, decomp, then replacement will help you kind of eliminate any confusion and kind of identify the easier ones first. Any questions? Please get a hold of me.